video to illustrate some of the effects of polymorphism in Java, the stuff that we're doing this week in the lecture. Now I'm using an example that we've looked at previously. This is the example. I'll just look at it. It's the point. So there's the point class. It has an x and a y coordinate, and it has get x, get y, set x, set y in a toString. Okay. The circle class, which adds a radius, so we can then find an area and a circumference. The cylinder class, which then inherits from a circle and adds a height, so we can now find a volume. Okay, so in the main class I created an object, a point object PT, and a cylinder object CYL. What I'm going to do is I'm going to create a generic object O, and I'm going to assign that to, which one will I do? Let's assign it to the cylinder. Okay. Oops. CYL. Sorry. Something had gone wrong. Right. So we've assigned it. So O is now an object of type object, but hidden behind that is a cylinder object. So we can do things like, if we do system.out.o.toString, you see when I type O dot, it only gives me the options for the methods from the object class. So if I click on toString, this is the odd thing, it only gives me the options for the methods from the object class, but in fact CYL is a cylinder. So when I run this, I will get the output. Now that's the output from the toString of cylinder. So although I'm using I'm using a toString method of object, it's applying the toString because it's overridden within the cylinder object on a cylinder object. I hope that makes sense. But we can do some other things a bit more interesting. Let's suppose, for example, we wanted, if I do O dot, it only gives me the options from the object class, but I want to run something from the cylinder class. Okay, well what I can do is I can cast the object by using, so class cast by using cylinder O. Now if I press dot here, it'll still give me the options from the object class, and that's a little mistake that you get, unless I enclose all of that within brackets. Oops, have I done that correctly? No, I need another bracket there, and then press the dot, and now because the O is class cast within the brackets, I'm applying a method on a cylinder object. So then I can choose, I could use toString if I wanted to, but I know what the output that is. But I could choose something like get volume, which I couldn't do before, and that should work. I can also do something like, I could turn it into, or I could turn O into a point object. Is that right? The right number of brackets. So if I do point O, that casts it as a point, and then I can go into here and I could choose get x, get y, toString, or is equal to. Let's choose get x. So print that. So the x coordinate is 0.0, and you can see that from the parameters that we passed over there. So you can do some simple things like that. So although O is a of type object, it's actually storing an object of type cylinder. Okay, so what would happen then if we tried to do something like, so if we did the same thing, I'm just going to edit this to see if I'm going to change it. If we did the same thing with the point object there, now you notice that all of these things still appear to work. So I could put another one in there. I could try this out, and circle, circle, O, dot, and it will give me all the methods of circle. But now when I try to run it, it should fall over. Yeah, we get a class cast exception, and it says that point can't be cast to a cylinder. So on this line here, O is an object, but it's actually storing, or it's referenced, or it's got a pointer to a point object. We can use the toString, that's fine, and the toString that we get is the toString of point. But when we try to convert it into a cylinder, it won't work, because we don't have things like a radius, we don't have a height, for obvious reasons. Okay, so that's a little illustration of how polymorphism works. Let's, if we put it back to, well, I should be able to, if I get rid of those two, I should be able to, now that will run. There's the x coordinates, so it runs okay. Remember that you can use instance of, so we could do something like O instance of object, and O instance of point, O instance of circle. If we run this, we should get true, true, and false, because a point is an object. An object is sorry, a point is a point. A point is an object, but a point isn't a circle. That's how that works. And if we change that line there to CYL and run this, we would get true, 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 because a cylinder is an object, a cylinder is a point, and a cylinder is a circle, as well as being a cylinder. I hope that helps. So remember, class casting is good, but you have to be careful to make sure it will allow you to compile the thing. But if you try to narrow it too much, then it'll all fall over and you get a class cast exception. Okay.